Hello, everybody. I wound up getting a question this week about this specific problem off of the homework. It asks us to find the domain of a given function. So to start out with, we're just going to take a look at it and see what aspects of it might be restricting us. So the first thing we're going to notice is that it's a fraction. So something that we know about fractions is that we cannot have a zero value in the denominator. It's just not allowed for math. Don't ask why. It's a very lengthy response, I think. And something else we notice is that it has a square root up top. And something we know about square roots is that they can't have a negative number in them. They can, but then it becomes an imaginary number, and for the sake of finding the domain, that really doesn't work, so we're going to act as though that's not allowed either. So the first thing we're going to do when looking at the domain is we're just going to take note of this radical up here and note that g of x must be greater than or equal to 0. It's a nice simple thing. We know that there can be a 0 in there, but there simply can't be a negative number in there. So that's the first thing we're going to write down. Now we're going to move on to this part of our function. The denominator, let's go ahead and rewrite it here. So 6x squared plus 5x minus 1. And what we're going to want to do with this is we're going to want to find where this equals 0. So let's go ahead and write a 0 right here. And we do this because we're only concerned with where this function can't exist. That's sort of the point of the domain. So this function can only not exist where this denominator equals 0. So to find where this denominator equals 0, we're going to solve this equation right here using factoring. So I'm going to go ahead and use the AC method of factoring. Go ahead and use any method you want. You can use a quadratic formula. You can just do it in your head. This is a pretty simple one, but for the sake of demonstration, I'm going to use this method. So for the AC method, we're going to take A and multiply it by C, which gives us -6. And now we're going to look for things that multiply together to equal -6, but add up to be B, which is 5. And right off the top of my head, we can right away see that 6 and -1 will be our answers for this. Because 6 times -1 is -6, but 6 plus -1 is 5. So just like that, we found we've used the AC method to work on our factoring. So now we're going to go ahead and plug in or rewrite our equation using what we learned here. So we're going to keep the first term the same, and then we're going to split up this middle term using the two values we found here. So we're going to do plus 6x, that 6 comes from here, minus x, that comes from here, minus 1. And this still equals 0. These two equations are still equivalent. So now we're just going to go ahead and we're going to factor these two terms here. We're just going to finally factor this by grouping. So from these two terms, we're going to factor out a 6x, just like that. And now we can rewrite what's left behind, which is x plus 1. And from here, we're going to go ahead and we're going to factor out a -1. And all we're left with is an x plus 1. And this is still equal to 0. So now we can finally just combine these two terms, being the 6x and the -1, and these two terms, which are the same, x plus 1. Now from here, we're going to set both of these two terms equal to 0. All right, so let's go ahead here. We have 6x minus 1 equals 0, and we have x plus 1 equals 0. So we're just going to go ahead and solve these for x. So this goes to 6x equals 1, which then goes to x equals 1 over 6. Perfect. And down here, this one's much simpler. Oh, forgot something. This x plus 1 should equal 0. And then from here, we just subtract 1 from both sides, and we're left with x equals -1. So we can finally go ahead and complete our domain for this. So these are the two values for our denominator that equals 0. We can go ahead and ignore this one because we already know from this up here that x cannot be less than or that x must be greater than or equal to 0. So we can go ahead and get rid of this. So now this is the only constraint that we haven't accounted for. Excuse me, this should just be not g of x is greater than or equal to 0, it's just x. So we know that the only thing limiting our equation is this and this. So to account for this, let's go ahead and write our domain in interval notation. So we're going to start with a bracket right here. And this is going to define the lowest our function can go, and this will be 0. Now recall you use a bracket whenever you have something that's greater than or equal to or less than and equal to. So if you have the and equal to sign here, you're going to use the bracket. This is very important. It's a very easy mistake to make to use the wrong one or just omit the appropriate interval notation, so make sure you're paying attention to this. And from here, the next thing limiting us is the 1 over 6. So get the 1 over 6. And for this, since it's going up to but not including 1 over 6, we're going to use a parentheses. Now we're going to include this union sign, and we're just going to go ahead and use a left parentheses followed by 1 over 6 again. Since the only number we're skipping over is 1 over 6, we're going to use these parentheses. And finally, this doesn't really have any bounds, so we're just going to put the final value in as infinity. And infinity also gets a parentheses, it doesn't get a bracket because we can't include infinity, we can just go up to it, we can approach it. So this is what our final answer should look like in interval notation. It's very important to remember these brackets and parentheses and remember which is appropriate for where. So again, if we're including it in our domain, we're going to use a bracket. If we're not including it in our domain, we're going to use parentheses. The union sign here just combines the two, so it just sort of indicates that we're jumping over. All right, I hope that answered your question, and I hope you have an excellent day.